Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing continue with the unit B of the K11 chemistry, which is the forms of matter and gases. And today we will end this unit by the last topic, which is the ideal gas law. This is a law which combines all the things we done so far in this unit and the new thing, which is the N, which is chemical amount of gas. So let's know what is that ideal gas law. So the ideal gas law describes the interrelationship between the pressure, temperature, volume, and the chemical amount of matter or the gas. And we had the four variables to define the gaseous system. So as we do first the Boyle's law, the volume of gas is inversely proportional to the pressure. That's we all do. That this is inversely proportional to the pressure. So next one, we do that the in Charles' law we do the volume of gas is directly proportional to the temperature, absolute temperature, which is like if one is increased, the other is also increases. So their volume is again now directly proportional to the temperature. Directly proportional, this is the inversely proportional. And then in Avogadro's law, that we're going to combine volumes, the volume of gas is directly proportional to the chemical amount of matter. So we do that volume is directly proportional to the n. From here we get the n. So all the things are in the volume state. That the volume, that all the things, volume is a relation between the pressure, temperature, and the chemical amount of gas. So from here we combine these three statements and produces the following relationship. So what is that relationship? That volume, if we have a constant of something, so we have 1p divided by into t into n, and this should be inversely proportional. So to get that proportionality sign, to remove that sign, we put the is equal to sign. So we put in the is equal to sign, and that always have p. Here we have t and n. So for that, we skip that, we like ignore the position, so we remove that, and we add the one constant instead of this. So that constant we use is r. So in this we put a constant r in this with a capital R, and that capital R has some value which is already in your data sheet. What is that value? We will know that's about. So that's the thing we get. But this is like not very like messy. You have to divide this. But we had in one like single thing, wanting like all thing nothing divide. So we get the thing like this. When you divide this p over there, so it's p times v is equal to nRT, which will give you this whole thing. PV is equal to n times r times t. From here, that P is your only pressure, not the initial, not the final. Now we're just doing the pressure, the volume in liters, this is in kPa always. The chemical amount is N, which is always in moles, and the T is temperature, always in Kelvin. That R is your proportionality sign, which is a universal gas constant. The value is 8.314 kPa times liter divided by mole per liter, mole times Kelvin. If you have the kPa, if you have a kPa, the pressure is in kPa, so you can use this constant term of that value of R. You can use this. If sometimes you have that all the pressure in atm, so we can't like do the kPa conversion to atm conversion to kPa. Instead of doing that, we just use the another value of R, which is 0.08206 atm dot liter divided by mole dot Kelvin. So this difference is that kPa is going to the atm. So if you want to use this thing and when you have atm, so you can use. Instant you have the other kPa thing. That's all you have to do. But sometimes you can't get the n directly. You can't get the n directly. Like n is this. Sometimes you get the mass. So do you get the molar mass? So from here you can introduce the n, the formula. So n is also equal to something. So n is equal to, that small n is equal to the small m divided by the big M. So what is that? N is chemical amount in moles. That m, the small m, represents the mass in kgs. Then capital M is the molar mass, which is in gram per mole. You know that how you can find the molar mass. When you do the questions, I will show you that how we can calculate the molar mass actually. But if you have that mass, if you have a mass and you want to find the n, So you can directly find that by n times m. Molar mass should always be given to us, and something you have to find by the chemical compound you have. If you have n and you have to find the mass, so you can do the conversion of sometimes. So the mass is equal to n times molar mass. This is the formula. You have to just isolate the things and get the things from here to. If you want to find the temperature, you can isolate the things and get the temperature. Just do the things which we do later on previous lessons. Do the same things in this to get the answers. Let's move on to the example. So for more clarity of this topic, so they mentioned the common use of ideal gas law is to predict the volumes or the mass of gases under specific conditions of the temperature and the pressure. For example, we have to predict the volume F. So occupied by the 0.78 grams of hydrogen at 22 degrees Celsius and 125 kPa. So from here you have a pressure, you have a temperature, you have a mass, and you have to find the volume. But we want n for this. We don't want the mass, we want the n. To find the n for this, so we have to find the molar mass first, because n is equal to mass upon molar mass. So they mentioned as 0.78 of hydrogen. So what is the molar mass of hydrogen? So hydrogen molar mass is equal to, so what is the atomic mass of H, which is hydrogen? So this is in your periodic table in the gram per mole in the element parts. For this is 1.01, which is in gram per mole, and this will be multiplied by 2, this thing, this H2. So you get this 2.02 gram per mole. This is your molar mass. You have a mass, so n is equal to 0.78 grams. Why this mass should be in grams? Because the grams will cancel out when you put this in. So this is 2.02 gram per mole. The gram cancel out, and when you divide this, you get this in moles. That's why I leave this in grams. So you get this like 0.3861. You have to use a non-rounded value in the formula, so I left it like this. And temperature also should be in Kelvin. So 22 degrees Celsius plus 273.15. You get about 295.15 Kelvin. Now the formula PV is equal to nRT, and you have to find the V. So it's nRT divided by P. So what is n? 0.3861 moles. And do you have a pressure in kPa? So you can use this 8.314. So 8.314 kPa dot liter divided by mole dot Kelvin. And your temperature is 295.15 Kelvin. This whole thing divided by P, which is pressure, 125 kPa. Now your kPa cancel out, your moles cancel out, your Kelvin and you get the volume in liters. Now when you solve this whole thing, you get something about 7.579 liters, which is about 7.6 liters. So this is your volume you have to find for the hydrogen. So that's all thing you have to do. The mass is given to us. Firstly, find the molar mass, then the n, and get the answer. Make sure you use the n be the non-rounded value to calculate the volume. That's the thought. So let's do one more example for more clarity. So a sample of a gas with a mass of 0.571 grams has a volume of 375 ml at 99.0 kPa and 23.8 degrees Celsius. Find the molar mass of the gas. You have to find the molar mass now. Means you have to find the capital M. This is the unknown gas, so that's what you have to find now. So this is your mass, this is your volume, this is your pressure. You have a temperature, so 23.8 degrees Celsius plus 273.15. You get this about 296.95 Kelvin. So this is your temperature. So find the molar mass. So for find the molar mass, you have to find the N. You have to find the N first. So PV is equal to nRT. You have this. You have to find the N over there. So you get PV divided by RT. So N is equal to what is P? P is 99.0 kPa. Your V is 375. Should be in liters. So this should be in liters. So you have to divide this by 1000. When you divide this, you get 0.375 liters. 0.375 liters. And you have to use the R of 8.14. So 8.314 kPa got liter upon mole dot Kelvin. And what's the temperature? 296.95 Kelvin. So that kPa cancel out, liter cancel out, Kelvin cancel out, you get the mole in answer. So you get about 0.015 moles. And you know that N is equal to mass upon molar mass, and what is molar mass? So that molar mass is equal to mass upon the chemical amount of gas, which is N. So which is mass? 0.571 grams. N is 0.015. Repeating moles. And what is the molar mass now? 338.06 gram per mole. You get it once, two set this to 38 gram per mole. Make sure this should be in grams. If it is in kgs, we have to convert this into grams, because molar mass has the units of gram per mole. And that's your answer. You find the molar mass, you find that. So that's all thing you have to do. They're not just asking about your from the PV and RT. There's something out about the N and then the molar mass, sometimes the mass. So that's the thing you have to be in mind, that how can we find the whole thing, and that all formulas so far we are doing in this unit, you have to memorize that. So that's all for this lesson. Now in the next lesson we do some practice questions, which we like combine all the laws and there are shuffled questions about this, and you have to recognize that which question is that about, which law this question is from. So that's all thing we do in the next lesson, practice questions we do. So learning with EduVibe, learn smarter, more and harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay guided with EduVibe.